we had a polynomial with 4 terms. 1, 2, 3, 4. There's no GCF for the whole thing. So we're going to break it into smaller pieces. We're going to break it into 2 groups of 2. And I'm going to factor a GCF out of this group, and I'm going to factor a GCF out of that group. When you factor out a GCF, it doesn't disappear. It comes out in front. What's the next GCF I'm going to factor out? This GCF that I factor out doesn't disappear. It comes out in front. Now, this is a negative. So a negative divided by a negative cancels out a negative. What's 10 divided by 5? And it has an X. 15 divided by 5 is 3. Negative divided by a negative is positive. Well, look at that. What happened when I did that? Do we have a common term now? Do you see that both of them have this 2x plus 3? This is where it gets a little bit fuzzy possibly for you guys because you haven't had a lot of factoring skills. But then step 3 is factor the common term. What do you see in common? What do you see down there twice? That becomes kind of like a GCF. That factors out in front. What's left? It is now factored. That is the answer to the factor. Let's check it to make sure. Yes. 2x plus 3, 4y minus 5. This is a check. You don't have to do a check on every problem, but we're just checking it out here on these first problems to show you that it really does. Now, if I could make my y's look like y's and my x's look like x's, do you see that we really do get what we started with? That's what we started with. We didn't have any like terms that would combine here, and so we have 4 terms. We don't have a trinomial. Now, well, I'll say that on the next problem. I'll save that comment. So we have 36, this is example number 2, 36x to the 3rd power plus 60x squared minus 9x minus 15. Step number 1 is always GCF. Does this have a GCF? And what is that GCF? And so I'm going to factor out a 3. The 3 that I factor out does not disappear. It goes out in front. Now, there's a reason I'm using this bracket instead of a parentheses. And so 3 will go into 36, 12. Oh, do they? No, they don't all have x's. 3 will go into 60. 3 will go into 9. 3 will go into, sorry, I'm not very good at bracket. It's because I am going to group them, and when I group them, I'm going to have parentheses, and so I'm going to have parentheses, and I don't want to have parentheses and more parentheses. That's why. Are you asking why I'm using brackets? Because I'm going to have parentheses in a minute, and so I don't want to have parentheses and more parentheses. Okay, now stop right there. Did I get the GCF? Look at this that's left. Is there another GCF that could come out? I mean, technically, it's not possible to have another GCF, but if you didn't get the biggest GCF, you check right there, and if there's something else coming that will come out, that wasn't the GCF. But anyway, it will not factor anymore. Okay, so then step 2 is 2 groups of 2. Two groups of 2. So what is the GCF for this group? 4x squared. What's the GCF for that one? It always has a GCF. If it has no other GCF, the GCF is 1. And if this is a minus sign, this has to be a minus sign. You always, to make the steps work, you have to have a GCF. If there's nothing else, the GCF is 1. And you'll see why, hopefully, in just a moment. So, when I factor out, I still have this 3 out in front, and I'm going to factor a 4x squared out of this first term. 12 divided by 4 is 3. X to the third divided by x squared. This cancels out 2 of those, and one of them is left. 20 divided by 4 is 5. X squared cancels x squared. Then I'm going to factor out a negative 1. 3, negative divided by negative makes that a positive. Negative divided by a negative makes that a positive. And look what I found. This term and this term are the same. So I factor out the common term. Step 3, factor the common term. So I have this 3 that's already out in front, the 3x plus 5, the double 3x plus 5, that factors out what's left. To check it, I would need a box problem. 4x squared minus 1. 3 times 4 would be 12x. X squared times another x makes it x to the third power. 5 times 4 is 20x squared. 12x to the third plus 20x squared minus 3x minus 5, and I would have to redistribute that GCF of 3 to get the exact with. If I did that, would I have the exact problem I started with? Now, as I said, you don't have to do a check in every single problem, but do you see that these steps are really working the box problem backwards? Box problem to divide. Back in the old days, we didn't do this by a step-by-step process. We did it by the process of called guess and check. And so I think that's what you're kind of talking about. Set up the box problem and just guess until you get it to work out right. Yes, that is a process that will work. This process works better. Try a few and see. X to the third power minus 4x plus 2x squared. This is not in standard form, but we'll go ahead and go with it. Does it have a GCF? It would have this part would have the whole thing, all four terms. This has a coefficient of 1, so I couldn't factor anything else out except a 1. This one doesn't have an x, so I can't factor out an x, so it does not have a GCF. So you go ahead and divide it into two groups of 2. What's going to come out of the first group? X or 1x. What's going to come out of the second group? And whatever this sign is right here, that's what this number needs to be. So when I factor out an x, what's left? X to the third divided by an x, that cancels one of those, so x squared is left. That cancels the x, so the 4 is left. I'm going to factor out a 2, and so the 2's cancel, and I have an x squared. 8 divided by 2 is 4. Look at that. Do you see a common factor? Not quite, because do you recognize this one as the difference of two squares? Is this a perfect square? Is this a perfect square? So this one right here factors into the plus minus pattern. And then this one is the x plus 2 that's on the end. Or, yes, that is the answer. Or you could write it as x2 squared x minus 2. You don't have to, but that's same. It's x plus 2 squared x minus 2. You don't have to. Once to solving, you need to know this technique. We're going to take this technique and show you how to apply it to trinomial. When the a is not 1, doesn't that sound fun? First step is always GCF. Is there a GCF? Then two groups of 2. Look at the first group. 15, 3. 3 will factor out of that. They both have an x. 10 and 2. Whatever this sign is, that's what I need to factor out. If this is negative, this needs to be negative. If it was a positive here, then I would factor out a positive. So I'm going to factor out what's 15 divided by 3? 5. And not squared, because the x squared is going to cancel one of those, and so it's just going to be 5x. What's 3 divided by 3? Nope. 3 divided by 3 is 1. X divided by x is 1. 10 divided by 2 is positive 5x. 2 divided by 2 is 1. Positive divided by a negative is a negative. Well, look what happened. I was going to talk about that just next. This is, okay, everybody see that I'm getting this one from the double term? Does everybody understand where I'm getting this one from? Okay, so the question always comes up, what if those don't match? Well, the usual reason they don't match is because you didn't use the GCF. Maybe you had some numbers like 16 and 8, and you used 2. Well, if your terms were 16 and 8, is 2 the GCF? No, you should be 4. So go back and check and make sure that you use GCF. That's one thing that will cause these not to match. The other thing that will cause those not to match is if it's not factorable. All of your homework problems have been set up so they are factorable. But, you know, we set them up so you can practice the method, but not everything factors. Everything on your homework factors, but not every polynomial in the whole world factors. So, if on your homework papers this doesn't match, then probably the issue is that you did not use the GCF. So, at this time, we have some problems for you to practice on.